6.4 is rational exponents. If we're going to talk about exponents today, we've got to talk about some rules about exponents before we get into a rational exponent. So let's remind you of some of your exponent rules from way back when. Okay, first one. Actually, let's label this as exponent rules so you guys can find them. I want to remind you that if you have x raised to the 0 power, anything raised to the 0 power is 1. If I have x raised to the negative n, remember that a negative exponent moves it where? What happens with a negative exponent? Moves it to the bottom. So this is 1 over x to the positive n. Or, what if I had 1 over x to the negative n on the bottom? It goes to the top. So this is x to the positive n. Negative exponent just moves it. All right. Next rule is if I am multiplying two bases that are the same. So let's say I have x to the n times by x to the m. If the bases are the same, we keep the base, add your exponents. Exactly. Let's say I have a base that has an exponent on it, but it's being raised to an exponent. Yep. Correct. We keep the base and we multiply the exponents. And then what if I have a base to the n divided by the same base to the m? We keep the base, and what do we do with the exponents here? Subtract. Very good. So it's n minus m. So some of these rules are going to come into play today and tomorrow. They're going to be important. Okay? So I wanted to make sure I reminded you of those. So when we talk about a rational exponent, is any exponent that can be written in fraction form. All right. So the easiest way is if I have x, which is my base, my fractional exponent, I'm going to write as p over r. The fractional exponent means power over root. Power over root. So for example, if I have, say I have x to the third inside a fifth root. This is the same as x to the power over root. Say I have the cube root of p. This is p to the power of 1 inside a cube root. Power over root. All right, so with that being said, we are going to start with the first section in our homework here. Example number 1. In the first section from 10 to 18, we need to simplify the expression. So let's start off with a really easy one. Let's say I have 16 to the 1/2. That means I have 16 to the first power inside a square root. Four, exactly. So this is 4. What if I had 2 to the 1/4 times by 2 to the 1/4 times by 2 to the 2/4? I have the same base that I'm multiplying. So I keep the base and I add my exponents. 1/4 plus 1/4 plus 2/4 equals 1. So this is just 2 to the first power, or 1. All right. Let's say I have 2 to the 1/2 power times by 32 to the 1/2 power. Those bases aren't the same, so I can't add the exponents, right? Oh, it is possible. Oh, but it is. You're right. So tell me about 2 to the 1/2. What actually is that? No. Let's try this again. Okay, this is 2 to the power over root. So 2 to the first power inside a square root, right? Times by 32 to the first power inside a square root. Since the roots are the same dimensions, we can multiply them together. This is the square root of 64. What is the square root of 64? Okay, same idea. Let's say I have, how about 3 to the 1/4 times by 27 to the 1/4. Gentlemen, good. 4th root. Okay, so the 4th root of 3. Correct. 4th root of 27. Correct. So it's the 4th root of 81, which equals 3. Okay? So in the first section, you're simplifying it. If you cannot put them together as fractional exponents, like in both of these cases, because the bases are different, change them into radicals. Okay? All right, here we are with example number 2. Example number 2 is going to cover 20 through 26. Write in radical form. So maybe they're going to give you something as wonderful and awesome as x to the 2/3. And I want you to write that in radical form. So I have x to the power of 2 inside a cube root. Exactly. What if I had y to the 6/5? And a 5th root. Now, what do you notice about this one? 1 can come out. Exactly. Very good. So I can take one group of y's out, and I'm left with only one y remaining. Okay, what if I had the 1.2. What actual fraction is 1.2? It is 6/5. I agree. That is a to the 6/5. Correct. So this is a to the 5th power inside, or sorry, to the 6th power. A to the 6th power inside a 5th root, which does simplify to a 5th root a. All right, let's do one more in this section. How about if I had, make this really good. What if I had r to the negative 2/3? Well, careful. Tell me about a negative exponent. Where does it actually move to? To the bottom. A negative exponent moves us to the bottom. So this technically is 1 over r to the positive 2/3. Then I need to rewrite that as 1 over r to the power inside a cube root. Oh, but what's wrong with that? Correct. So what do we need to do, Preston? We need to multiply by the cube root of what? No, just r. Yep, just r. So I'm going to times the top by the cube root of just r. On the top, I get the cube root of r. On the bottom, I just get r. All right, example number 3. Example number 3, this is going to cover 28 through 34. In this section, I want you to write it in exponential form. So maybe you are given the square root of 13. How would I write that in exponential form? (13 to the 1/2). 13 to the 1st power inside a square root. Let's say I have the cube root of 2x squared. That is a whole group I have underneath that cube root, isn't it? So I'm going to leave this as a group of 2x squared and raise it to the 1/3 power, exactly. All right, what if I had the 4th root of d squared? D to the 1/2, correct. D to the 1/2. So, on that SAT packet we did, this similar thing happened. Remember how we had a 3 that started off as 3 to the 2nd inside a 4th root? And we brought that back out and rewrote it as 3 to the 1/2. So if I wanted to change this back, this would be d inside a square root, right? This, and the square root of d are all the same, exactly. All right, so any questions writing it in radical form? Or writing in exponential form, sorry, my bad. Okay, example number 4. Example number 4 is going to cover your 36 and 38. If you are given an equation, h equals 0.00252d, to the 2.27 all over E, and I ask you to find H when D equals 30 and E equals 5. What do you think you're going to do with those two values? Plug them in. So you're going to grab your calculator and type this in. You're going to have H equals 0.00252 times 30 to the 2.27 divided by 5. And I don't have a calculator up here, so somebody's going to tell me. $1.136. All right, so we're good? That's all you have to do for those couple of problems. Now, last example today, example number 5. Example number 5 is going to cover your 40 and 42. And I'm going to ask you to find the product or quotient. All right, so let's say I have x to the second inside of fourth root divided by the square root of x to the fourth. I don't know, that sounds good. All right, so first of all, we can't reduce that fraction. Why? Because they're different dimensions, right? Those radicals are different dimensions. So the first thing we're going to do is change them into fractional exponents. So on the top, this is going to become x to the 1/2. I agree. 2 over 4 is 1/2. Over the bottom, which is x to the fourth inside of square root, is x squared, right? Okay, so now when we were dividing with the same base, what do we do with those exponents? Subtract. Look back at those rules we talked about. We subtract our exponents. This is keep the base and subtract the exponents. So we're going to have x to the negative 3/2. Where does that negative exponent go? On the bottom. So this is 1 over x to the third power inside a square root. Now what can I do to simplify that? Not yet. What can I do? Yeah, we can take out an x. So I have 1 over x square root x. Now what? Times by the square root of x to the top and the bottom. So we end up with the square root of x over x to the second. Very good. Okay. Well, just 1 second. Let's do a multiplying one before you. Yeah. Let's say I have the 6th power of 6, or the 6 through 6 times by let's go times by the 4 through to 6. Well, I can't multiply those together, right? Different dimensions. However, let's see what happens if we change them to fractional exponents. So I have 6 to the 1/6 times by 6 to the 1/4. Do I have the same base? Which means I can keep the base and do what with my exponents? 1/6 plus 1/4. Oh my goodness, guys. I agree we can go to 12. So this is actually going to be 2 over 12 plus 3 over 12. So we get 6 to the 5 over 12. Oh. All right, now, it started in radical form, so how do you think we need to finish this? In radical form. So that means I'm going to have 6 to the 5th power inside a 12th root. All right. So your homework today, you're doing 10 through 42 even. Not that many. Some of them are super, super quick. We're going to continue this lesson with more of the multiplying and dividing tomorrow. But we've got to make sure we remember all of our rules before we can keep going. Okay? Thank you.